All right, guys, so this is the beginning of Module 2. So Module 2 is going to take us through a review of transformations, which was actually the first thing that we learned this year. So this module will be done with by Friday. This is a very quick module. There's not a lot of tricks or sneaky ways to ask questions. So this is just the review of the content before you get started on your practice quizzes. So transformations, if we remember, are operations that move points in a coordinate plane from one location to another. So when we were dealing with transformations, there were 4 transformations that we learned about, and 3 of them had something in common, and 3 of them are called congruence transformations. And a lot of you know that the word congruence means equal. So basically, these are transformations that occur that take the original shape and they move it, but the new shape is still equal in size. So if you found the area or the perimeter of the new shape, it would be exactly the same as the original shape. And let's also remember the original shape is called the pre-image. So I could have like point A, and the new shape is called the image. And I would indicate that it was the image by putting a prime sign by the symbol. So congruence transformations are the 3 transformations that retain the size and the shape. So the first one is translations. And translations are, well, we'll get to them in a little bit. And then we're going to have rotations. And finally, we will have reflections. So those are 3 of the transformations that we have learned about. And then we also learned about one more transformation, and this one was a non-congruent transformation. So this one changed the shape of the figure, and it changed it by making it larger or smaller. So some of us are remembering that this here was called a dilation. And even though it's not congruent anymore, the shapes will still be similar, because if you have a figure, like let's say this is 2 by 4, and you were to dilate it with a scale factor of 2, it would become 4 by 8. So whatever you multiply, whatever scale factor you use for one of the side lengths, you have to use for all of the side lengths. So they remain proportional, and then they are similar figures. So we're going to start by looking at these one at a time. So the first one that we're going to look at is translations. So we should remember that translations move points horizontally and vertically along the coordinate plane. So the coordinate rule is that I'll be given some coordinate, some x, y, and I will have to perform a translation. So I'll take the x coordinate and I'll either add or subtract some number, and that's going to allow it to move to the left if I subtract or to the right if I add. And then I'll have my y coordinate, and whatever that is, I'll add and subtract some number. It could be the same number, could be a different number, but while the x coordinate moves it to the left and to the right, if I add to the y coordinate, it goes up, and if I subtract from the y coordinate, it goes down. So right here, I guess that's supposed to say point R. So this point is moved 6 units down and 9 units to the right. So, and it wants to know what the new location is going to be. So the most important thing here is to recognize that this 6 goes with the word down. So this is saying y minus 6. If you don't do that to the y coordinate, you're going to get the wrong answer. And then 9 units to the right is x plus 9. So your original point here was 5, 6. And your rule tells you that you need to go to the x coordinate and add 9. And you need to go to the y coordinate and subtract 6. And that's going to give you the location of r prime. Well, 5 plus 9 is 14, and 6 minus 6 is 0. So the location of r prime would be at 14, 0. So the next question here tells us that point Q is located at 4, negative 3, and then it says that point Q prime is located at negative 2, 1. It wants to know what translation rule allowed that to happen. Then it gives me a new point and says, according to that same rule, where will S prime be? So I need to think about what rule has already happened here. So point Q was located at 4, negative 3, and point Q prime is located at negative 2, 1. So I need to figure out what has happened to the x coordinate, and I also need to figure out what has happened to the y coordinate here. Well, I've gone from positive 4 to negative 2, so I know that I've subtracted. And to get from positive 4 to negative 2, that's subtracting 6. So my x-coordinate rule is x minus 6. Then I'm going to go to my y-coordinate, and I've gone from negative 3 to positive 1, so I've added. While it takes me 3 to get to 0 and then 1 more to get to 1, so I've added 4. So I go to my y-coordinate rule, and that's y plus 4. So what's happened is that this point Q started at 4, negative 3. It moved 6 units to the left and then 4 units up. So now we have point S, and point S is located at 5, negative 4. And we need to take that point and we need to move it 6 units to the left and 4 units up. So I'm going to apply my rule here. To my x coordinate, I'm going to subtract 6. To my y coordinate, I'm going to add 4. And point S prime will be located at negative 1, because 5 minus 6 is negative 1, and negative 4 plus 4 is 0. So that is where point S prime will be located. All right, so we're going to look at reflections, and what reflections do is they flip a figure or point an equal distance across a line of reflection. So in math 8, the only lines of reflection that we use are the x-axis and the y-axis. So if I'm reflecting something over the x-axis, basically this is my x-axis down here, right? So if I start with a point up here, I'm going to reflect it across the x-axis. So let's say this is currently at positive 2, 2. Wow, that does not look good. Oh no, and now I've messed up the whole thing. I don't, why? Oh no. Okay, we're just gonna ignore it. All right, so if this is at positive 2, 2, and I reflect it over the x-axis, well, it's currently 2 units above the x-axis, so now I need to move it 2 units below the x-axis. So now that point is still at the x-coordinate of 2, but it's not at positive 2 anymore, it's now at negative 2. So what it's done is it's flipped this across an equal distance across the line of reflection. So it was 2 units to the line of reflection, so now it's 2 units to the new point. So each one is the same distance from the line of reflection. So when you reflect something over the x-axis, what happens is the y-coordinate changes. So what that means is if the y coordinate was positive, it becomes negative. If the y coordinate was negative, it becomes positive. So the y coordinate changes. And the way that we write that is we take that point x, y, and it becomes x negative y. And remember, that doesn't mean that the y value has to be negative. It means that you change the sign of the y value. So if it is positive, you make it negative. If it is negative, you make it positive. So reflecting over the y-axis is very, very similar, except now you're taking some point. So let's say you're taking this point. Let's say that's -1, 2. And now you're reflecting it over a vertical line. You're reflecting it over this axis here. So now it is over here. Well, now its x coordinate isn't negative anymore because it was used to be 1 unit to the left of the y-axis, but now it's 1 unit to the right of the y-axis. So it's +1, but my y coordinate hasn't changed. It's still on that same horizontal line. So that's +1, 2. So what happens when you reflect over the y-axis is the x coordinate changes. So if you're looking at a point x, y, you end up with -x, y, because when you reflect over the y-axis, the value of the x coordinate changes. So if it were positive, you make it negative. If it's negative, you make it positive. All right, so 3 example problems. So it says that point F is reflected across the y-axis, and it wants to know what is the point of F prime. So if it's reflected over the y-axis, we change x. So I need to change x here. The way that I change x is I take my original point. My x coordinate is currently -4. So for f prime, all I have to do is change my x coordinate. So I make it +4, 5. All right, so for the next one, it tells you that you have point D, and then it tells you that you have point D prime. And it wants to know what axis did the point reflect over. So point D was located at 3, -8. Point D prime was located at -3, 8. Ooh, interesting. And it said, what axis did the point reflect over? Well, I notice here that my x coordinate changes, right? So it must have reflected over, if the x coordinate changes, it means it reflected over the y-axis, right? But if I look here, what happened to my x coordinate? It also did what? It changed. So I reflected over my y-axis and my x, and it's not your axis, it is just the x-axis. Now, some of us might have also noticed that in this point, the coordinates stayed in the same place, but each one of them changed signs. So the positive became negative, the negative became positive. So not only is this a reflection over the y-axis and also the x-axis, it's also a rotation. Think for a second about what rotation rule it is. It is 180 degrees. So 180-degree rotation is the same thing as reflecting a point over the x-axis and the y-axis. All right, so let's look at C here, and it tells us that C is located at 6, -8. Then it says the point is now located at 6, 8, and it wants to know what reflection occurred. Well, the x coordinate stayed exactly the same, but the y coordinate changes. And we know that when the y coordinate changes, you reflect over the what? Yep, you reflect over the x axis. So what has happened right here is a reflection over the x axis. All right, So rotations are the last type of congruence transformation, the last type of transformation where the figure stays exactly the same size. And what rotations do is they turn all points in a figure around a center of dilation. So it turns all points in a figure around a center of dilation. So there are three rules. Two of them are alike, one of them's a little different. So the ones that are similar are the ones that are counterclockwise and clockwise. They sound similar. Ooh, there's an error on here too. This should not say 90. This should say 180, and 180 degrees clockwise is the same thing as counterclockwise because a circle is 360 degrees. So if I go 180 degrees in that direction, it's the same thing as going 180 degrees in that direction. All right, so let's start with that 180 degrees because we've actually already talked about that one in this review video. So in 180 degree rotation, we actually said that's the same thing as a reflection over the x-axis and a reflection over the y-axis. So in a 180 degree rotation, the coordinates stay in the exact same spot, but both of them change signs. So if the x was positive, it becomes negative. If it was negative, it becomes positive, and then same with the y. So the trick about clockwise and counterclockwise is the direction. And if you do it according to the way that I'm describing it, it is much easier than if you try to change the symbols in your head. So counterclockwise is to the left. So I'm going to take my ordered pair, x, y. And what happens in any 90-degree rotation is the coordinates change places. So instead of x, y, I'm going to have y, x. Now, at this point, I need to think about clockwise or counterclockwise. Well, counterclockwise is to the left, so the coordinate on the left is the one that changes. So it will become whatever xy becomes will become the opposite of whatever that y was is now the leading coordinate followed by x. Clockwise is almost the same thing, except clockwise moves to the right. So you're going to start with an ordered pair, x, y, and you're going to rotate it. Well, it's 90 degrees, and in all the 90-degree ones, they change places, so it becomes y, x, and now clockwise is to the right, so I go to the coordinate on the right, and that is the one that changes. So let's go ahead and see what these look like when you're using your rules here. So the first question gives us point G. So point G is currently located at -4, -2, and I need to turn it into point G prime. It tells me that it is rotated 90 degrees clockwise, that is to the right. So I'm going to take my points, and I know in a 90-degree rotation they change places. So instead of -4, -2, I'm going to write -2, -4. All I did was change the order. Now, 90 degrees clockwise means go to the coordinate on the right and change it. So now I actually have that G prime is located at -2, +4. All right, so number 3 is telling us that we have point J. So we have point J that is 5, -1, and it tells us we're going to rotate it 90 degrees counterclockwise. So that's to the left. So for point J prime, since it's a 90-degree location or rotation, they change locations. So I'm going to write -1, 5. Then, since it is counterclockwise, I'm going to go to the coordinate on the left, which is this -1 here. I'm going to change it. So J prime is located at +1, +5. The last question is a released EOG question. So it tells you that you have this triangle and these are its vertices, and it's saying it's being rotated 180 degrees. So we get xy, and in 180 degrees, do the coordinates change locations? No, they don't. That's only in 90 degrees. So I still have xy, but what happens in a 180 is both of them change signs. So they're telling us to focus on y. So y is currently located at 3, 5. So y prime is going to be located, when I change both of those coordinates, to -3, -5, and that gives us answer choice B. All right, so dilations are going to be things that are still considered transformations, but what makes them different is that they change the size of the figure. So dilations are a transformation that reduces or enlarges a, a figure proportionally. And that is the most important word here. Proportionally. So what that means is that if you have a figure, let's say we have a scalene triangle. So let's say this is 5, this is 7, this is 8. So it's scaling because they're all different. If I'm going to perform a dilation, the only rule is that whatever scale factor I use that same scale factor on all 3 numbers. I can't multiply these by 3 and this by 2. In order for it to be a dilation, in order for it to be proportionate, I have to multiply all 3 pieces by the same number. So if I want to create an enlargement, I use a scale factor that is greater than some value. And if I want to make it larger, I need to use a scale factor that is greater than 1. If I want to create a reduction, I need to use a scale factor that is less than 1. And anytime you are doing a dilation, you are using multiplication to do it. Multiplication is the operation that allows us to perform a dilation. So I look right here at this example question, and it tells us that we have point L, which is located at 2, 5, and it's dilated to become L prime, which is located at 6, 15. Well, first of all, I'm going to look at my points here. I started at 2, now I'm at 6. I started at 5, now I'm at 15. So have they gotten larger or smaller? Most of you already recognize these have gotten larger, so I know that I'm going to have a scale factor, and scale factors in dilations are represented with the variable k. So I know here I'm going to have a scale factor that's greater than 1. So now I have to think, well, what number do I multiply 2 by to get 6? Well, I'm going to start thinking, and I know that 2 multiplied by 3 is 6. Okay, well, let's check that scale factor. What is 5 multiplied by 3? It is indeed 15. So we know that our scale factor here is equal to 3. All right, this is going to be your last review question before you begin the transformations practice quiz 1. So right here you've got a triangle, and it is a right triangle, and it tells you that it's being dilated with a scale factor of 1/2. So we already know that the figure is going to get bigger or smaller. Smaller, yes, that's correct. And yeah, I'm talking to myself now, guys. Hopefully you're answering these questions. And it's getting dilated with a scale factor of 1/2. So basically, I need to know where each of these ordered pairs are going to be after I multiply them by 1/2. So I'm going to write their original locations. So point L is currently located at -3, 4. And point M is currently located at 3, 4. Point L and M are both 3 units away from the y-axis. So point L is actually a reflection over the y-axis of point M, or vice versa. And then point N here is located at 3, 1. So basically it's saying that I'm going to multiply each of these by 1/2. So -3 times 1/2 and 4 times 1/2. Well, -3 times 1/2 is -1.5, and 4 times 1/2 is 2. 3 times 1/2 is positive 1.5, and 4 times 1/2 is still 2. Then n, so 3 times 1/2 is going to give me 1.5, and 1 times 1/2 gives me 1/2, so 0.5. So this is point L prime, M prime, and N prime. So at this point, I can go look at my answer choices. So L prime, that matches, M prime, that matches. So we're looking here for answer choice C. So hopefully that was a good review of transformations for you, and you feel ready to go into that practice test. Shouldn't be so bad. All right, please get that done tonight. That's not like do it soon. It's do it tonight so that tomorrow I can post the answers in the next quiz. And it's not helpful if you don't do the work quickly, because if you sit around and wait, then all you're doing is waiting for the answers, and that's not helping you. So please stop doing that. Please get the work done. This does not take that long now that you've watched the video. This is the only video this week where you have to watch the whole thing. For all the rest of them, you only have to watch about the questions that you missed on the practice quiz. Excuse me, on the practice quizzes. All right, I hope you guys are doing well. I miss you, and I'll see you guys on a Zoom call sometime soon. Bye.